Okay, so welcome back to Unit 5, Day 9 practice. We're predicting products of precipitate reactions. So let's start by dividing our cations and anions for our reactants. So the metal, what's written first, is our cation, and then what the nonmetal part that's written second is our anion. And I do this so that I know which partners will switch when I form my products. Okay, so that part's done. And now what I'm going to do is I'm going to switch them around to form my new products. So the first product will be formed from the first and the last. So the first cation and the last anion. So I'm going to get BaSO4. And then my second one is going to be, remember I write the copper first because it's a metal, CuCl. Now you may be thinking, shouldn't that be Cl2? We don't know that quite yet. So we don't know if this is supposed to be a Cl2. This 2 just tells me that there are 2 chlorines in this compound. But the key thing is, I'm just looking for whatever the anion is. The only time I include the subscripts when I rewrite it over is for a polyatomic. SO4 is a group, okay? Those 4 oxygens belong with that sulfur to make that anion, okay? So that's a group, so they're going to move over. But when it comes down to the monatomic anions, the anion is just made up of one type of nonmetal. For those, don't move the subscripts. Don't move them. You got to figure them out to see if there should there be 1 here or should there be 2 here. And that's similar to what we did in example 1. So in example 1, we start off with FeCl2. Notice that when I made my product, I just moved over 1 chlorine. I switched just 1 chlorine, I switched it with the sodium, right? I didn't write NaCl2. And if I would have written NaCl2, that formula would have been wrong because it would not have canceled out. Okay. All right. So going back here, I got my copper chloride. So I'm going to go ahead and check these formulas to see if they're correct. All right. So starting with barium sulfate. Barium is in group 2. So if it's in group 2, here's barium down here. It has a +2 charge. So now I need to check to see what the charge of my polyatomic is. Sulfate is in has a -2 charge. Just look on my chart here, find sulfate, has a -2 charge. Okay, so once again, this formula is correct because if you add these charges together, the overall charge is 0. Now we're going to go ahead and look for copper. Now copper is a transition metal, right? So here's copper, it's in that transition metal section. So I have to figure out the charges. So to figure out the charge of that, of the copper in the product, I need to go back to the reactant. And when I go back to the reactant, I find the reactant that has copper in it. And I know that the overall charge of this compound is 0. So the overall charge is 0. So now I need to figure out, well, what's the charge of the anion? This is a polyatomic, so I look on the chart here. It has a -2 charge. Okay? So now I'm asking myself, well, what plus -2 will give me an overall charge of 0, right? So that's a question mark there. What goes there? So the answer to that will be +2. +2 plus -2 will give me an overall charge of 0. So that means that the copper here has a +2 charge. All right, now chlorine has a -1 charge. I know that because it's in group 17, so it has a -1 charge. Okay, perfect. All right, so now in this example, notice that the charges don't cancel out, +2 and -1. If I add those together, are they going to give me 0? Nope, they don't give me 0. So now I need to figure out, well, how do I correct this formula? So to correct this formula, if the copper has a +2 charge and the chlorine has a -1 charge, that means I'm going to need 2 chlorines in order to get the overall charge to be 0. I'll need 2 of these, right? Because 2 times -1 will give me -2. Add that to the +2, and that gives me 0. So now, what I'm going to do here is I'm going to add a subscript of 2. All right, and then I'll just outline it in green so we can see. And that comes from the fact that I know I needed 2 of those to get the overall charge to 0. So in this example, a couple of things that are important about this example. One, when we formed our product by switching our cations and anions, for copper chloride, we didn't write CuCl2 right away. We just wrote CuCl. And the reason why we just wrote CuCl is because we don't know yet how many chlorines that we need. It could be 2, it could be 3, it could be 1. We don't know yet. We have to figure that out. And the next thing that is important about this example is that to figure it out, what we did was we checked that the overall charges of the cation and anion, if you add them together, give you 0. In this example, copper, our cation had a +2 charge, our anion and chlorine had a -2 charge. So it didn't give us an overall charge of 0. So we needed 2 chlorines to get the overall charge of 0. So that's where that subscript 2 comes in. Okay? It doesn't come from just because I saw it here, that means it goes here. This just happens to be a coincidence. It does not always work that way. All right. We've got one more example that we're going to do, and actually what I'm going to do is I'm going to switch with you. So for CFU1, I think this is corrected on your document, I'm going to switch that with this one here. So the next example that you're going to see is going to be this one, number 6.